going to move on to slightly trickier examples, but remember there's always a strategy, and if you remember the strategy, they're not too difficult. So we're going to look at mixing substances at two different questions, and these are similar to exam type questions. And this example is from the Dominic Donnelly textbook, page 237. So what do we have? We have a bell which is made of bronze, and bronze is an alloy of copper and tin. The bronze has a relative density of 8.55. So the density of bronze is 8,550, and it's made up of copper and tin. The copper has a relative density or a density of 8950. They give us the relative density, but I prefer to work in densities. The tin has a density of 7350. So the copper and the tin is added together to give us the bronze. And the question is, by what percentages by volume are copper and tin added together? So we don't know anything else. We don't know the total volume of the bronze. We don't know the volume of the copper. We don't know the volume of the tin. But we want to know what percentages of each there is in the alloy. So remember, the way to always start these is total mass, or let's call it mass of the bronze, is equal to mass of the copper plus mass of the tin. We know density equals mass over volume, so mass equals density times volume. So we can say the density of the bronze times the volume of the bronze equals the density of the copper times the volume of the copper plus the density of the tin times the volume of the tin. Now we want to reduce the variables. We know the densities, so we could actually fill them in if we wanted. This could be 8550 VB equals copper was 8950 VC, and then tin was 7350 VC. Sorry, that should be tin VT. So what we want to do is we want to reduce the variables, and we want to get a ratio essentially of copper to tin. So how we do that is we look at this VB here and we replace it, and this came up in one of the other questions that we've done before. Instead of writing V bronze, we say, well, the total volume of bronze would be equal to the total volume of copper plus the total volume of tin. So we're rewriting this as these two variables, and we already have those variables in the equation. Here we have VC and here we have VT. So we're reducing the variables in the equation by 1. And now this will allow us to get a relationship between the volume of copper and the volume of tin, and then we can figure out percentage wise what's in each, or how much of each is in the bronze. So 8550 VC plus 8550 VT equals 8950 VC plus 7350 VT. Let's bring the like terms together. So we'll bring this to the other side, and then we bring this over to this side, and we'll be left with 8950 VC, take away 8550 VC, equals 8550 VT minus 7350 VT. Keep going then, and we're left with 400 VC equals 1200 VT. Divide across by 400, VC equals 3 VT. Now here's the tricky bit, but you just have to use a bit of logic. So however much copper is in the alloy of bronze, there's 3 times as much tin. So we could say that there's 4 parts, and those four parts are split into 3 parts of either copper or tin, and 1 part of either copper or tin. Now be careful, don't just read it and say there's 3 parts of tin. There's actually 3 parts of copper for every 1 part of tin. Why? Because it takes 3 times the amount of tin to equal the amount of copper. So the 1 part, which is going to be 25%, is going to be the tin, and the 75% is going to be the copper. And if we work backwards, we can see that if we multiply the volume of tin, 25 by 3, it's equal to the volume of copper. So that's your answer, 75% copper, 25% tin. That's part 1 of the question. Looking at part 2 then, we have a bell of mass 10 kg is made from bronze. Find the mass of copper and the mass of the tin required. Okay, so we're going to have a full bell, which is made of bronze, and its mass is going to be 10 kg. The density of bronze is 8550 kilograms per meter cubed. And this bell is going to be made up of 75%, what was it, copper, wasn't it? 75% copper and 25% tin. Okay, so first of all, let's get the volume of the bell. So density equals mass over volume. So volume equals mass divided by density. So 10 divided by 8550. So the volume of the bell is 1 over 855 meters cubed. Now remember, that's the volume of the total bell. So we know that 75% of this is going to be copper. So let's get the volume of the copper. The volume of the copper will be 75% of 1 over 855. Let's put that into my calculator, 0.75 multiplied by 1 over 855, which is 1 over 1140. So now if we want the mass of copper, mass is going to be the density of copper times the volume of copper. So the density of copper was 8950 multiplied by 1 over 1140, and that gives us an answer of 7.85 kg. Now if we want the mass of tin, well, the overall bell weighs 10 kg, so it's going to be 10 minus 7.85, which equals 2.15 kg, and that's your answer. So as I said before, it's all about breaking down your variables and starting off with that equation. Starting off with this equation is the key to solving it.